Hello guys, welcome to my YouTube channel. In this video, I'll be showing you how to solve these problems. But please subscribe and also like. Thank you very much for your support. Alright, let's get started. Alright, to solve this question, first we introduce the formula, which is d dx of u equals to negative 1 over 1 plus u squared du dx. Next, we identify the value of u. So u is simply root x. So u is equals to the square root of x, and the square root of x is also x to the power of 1/2. So if we are going to take the derivative of u, then the x will be equals to 1/2. So you simply switch this 1/2 over here and then subtract 1 from the power, which is 1/2, and that gives us x to the power of negative 1/2. And we can also write this as 1/2 times 1 over x to the power of 1/2, and this will be equals to 1/2 times 1 over the square root of x, and finally this will be 1/2 times root x. So this is the derivative of u. Now let's go ahead and find the derivative of y. So the x will be equals to negative 1/1 plus, remember that u is root x, so this is now root x squared times du dx is simply this, so that is the value of du dx. So let's transfer that here. So 1/2 root x. So if we multiply this, so this will give us negative 1/2 root x times 1 plus root x squared is x. Okay, so this is the answer to the question, and we can also just write it as negative 1/2 root x to root x 1 plus x. Okay, so that is the answer to this question, and I hope it makes some sense. Alright, let's move on to the next question. Alright, question 2. So we also need to start with the formula, which is d dx of and this is equals to negative 1 over the absolute value of u times the square root of u squared minus 1 du dx. Next, we need to identify the value of u, and u is simply this. So this is equals to exponential to the power of x, and if we take the derivative of u with respect to x, this will also give us exponential x. So now we can take the derivative of y. So if we differentiate y with respect to x, this will be equals to negative 1 over the absolute value of exponential to the power of x times the square root of exponential to the power of x squared minus 1 times du dx. So du dx is this is the value of du dx, so we need to transfer that over here. Good. So now the absolute value of exponential to the power of x is the same as exponential to the power of x times exponential to the power of x squared is the same as exponential to the power of 2x minus 1 times exponential to the power of x. So this can simply cancel this from here, and finally we are going to have negative 1 over the square root of exponential to the power of 2x minus 1. So this is the answer to this question, and I hope it makes some sense. Alright, let's go to the next one. Question 3. We also need to start with the formula d dx sec negative 1 u is equals to 1 over the absolute value of u times the square root of u squared minus 1 times the u dx, and we need to identify u. U is simply x to the 5th power. So if we differentiate u with respect to x, this will be 5x to the 4th power. So now let's take the derivative of y with respect to x. So this will be equals to 1 over the absolute value of x to the 5th power times the square root of x to the 5th power squared minus 1 times the u dx. The u dx is simply this, so let's transfer that over here. So we have 5x to the 4th power. So now the absolute value of x to the 5th power is still x to the 5th power times the square root. X to the 5th power squared is x raised to power 10 minus 1 times 5x to the 4th power. So x to the 4th power can simply cancel x to the 4th power from here, leaving you with x to the power of 1, which is the same as x. So this 5 excuse me, this 5 can multiply this 1 to give us 5 over x times the square root of x to the 10th power minus 1. So this is the answer to this question, and I hope it makes some sense. So if you find this video useful, don't forget to subscribe to this channel, like the video, share the link with your friends. Thank you very much for your support. Looking forward to seeing you in our next video. Bye bye.